Ancient civilizations moved stones heavier than 10 elephants across miles of brutal wilderness. This is the mystery of how enormous basalt blocks were transported across seemingly impossible terrain. By the end of this journey, you will understand the forgotten engineering that made these colossal journeys possible. We will uncover how master builders guided multi-ton stones over mountains and across rivers, and why entire cultures dedicated generations to this back-breaking work. The answers lie in a blend of simple tools, brilliant physics, and profound human determination. What does it truly take for a community to move a mountain, one stone at a time? Its durability came at a steep price in weight. This dense volcanic rock, born from fire and rapidly cooled lava, is one of the toughest materials found in nature. Forming vast, intimidating landscapes of columnar cliffs and sprawling flows, basalt was quarried directly from these specific, often remote, sources. Ancient builders sought it out precisely because it could withstand centuries of weathering, creating monuments meant to last for eternity. Yet this same immortal quality created an immense physical challenge. The very locations that provided the finest, most unbroken stone were frequently situated far from the sacred sites or city centers where the blocks were destined to stand. This geological reality imposed a brutal equation on every project. The choice of material automatically meant accepting a logistical nightmare, a puzzle of distance and mass that would demand a brilliant solution. To grasp the full scale of their achievement, we must first visit the origins, the dramatic quarries where these monumental journeys began. The quarries themselves are a testament to the first great challenge, the extraction of the stone. At sites like the famous Rono-Roroku on Easter Island, the evidence is carved directly into the landscape. Workers did not have modern metal tools, instead relying on harder stones to pound and pick at the basalt, patiently exploiting its natural weaknesses. They would locate existing fissures in the rock and drive wooden wedges into them, then soak the wood with water. As the saturated wood expanded with immense, relentless force, it would fracture the basalt along clean, predetermined lines. In other parts of the ancient world, a different kind of alchemy was at work. Builders would light controlled fires directly against the rock face, heating the dense stone. Then, just as the basalt reached its peak temperature, they would douse it with cold water. This thermal shock, the sudden and violent contraction of the stone, caused it to crack, allowing huge, manageable blocks to be split away from the living bedrock. These were not acts of brute force, but of profound understanding. Every strike, every carefully placed fire, was guided by generations of accumulated knowledge, minimizing waste and shaping the perfect block. Walking through such a quarry today is like stepping into a workshop frozen in time, with half-finished monoliths still clinging to the earth, a silent story of ambition and skill carved into the stone. But the true, overwhelming puzzle began the moment a block was finally freed, lying loose and colossal at the base of the quarry wall. How do you even begin to move a small mountain? The first step was to get it onto a pathway it could actually travel. The moment a block was freed, the real test of ingenuity began. That colossal stone, now lying at the foot of the quarry wall, was utterly immobile. The first and most critical step was to coax it onto a transport system, a feat of physics and human coordination that was anything but simple. At places like Baalbek in Lebanon, home to the largest known building stones in the ancient world, you can still see the evidence of this initial struggle. The solution was often a carefully constructed earthen ramp, a temporary roadway built right up to the resting place of the stone. Teams of workers would then employ a symphony of simple tools. Massive wooden levers were inserted beneath the block's edge. With coordinated shouts and heaves, men would push down on the levers, lifting one side of the stone just enough to slide a wooden roller or a greased sledge underneath. Think of trying to move a refrigerator that weighs as much as a small apartment building using only logs and ropes. Every motion was incremental, a battle fought inch by exhausting inch. The ground itself was the enemy. A slight incline, a patch of soft earth, or a single unseen rock could bring the entire operation to a grinding halt. This demanded not just brawn, but constant problem-solving. If the ground was too soft, they might lay down a temporary road of wooden planks. If the block became stuck, they would reposition levers and rollers, finding a new point of balance. The success of this first, short journey from its quarry bed to its transport sled was absolutely critical. It was the foundation upon which the entire, incredible cross-country journey depended. This monumental effort to simply get the stone moving leads us to the next great puzzle: the methods proposed for the actual transport of these giants across miles of open land. The sledge and roller system stands as a masterpiece of ancient engineering, transforming an impossible burden into a manageable, if arduous, procession. Imagine a colossal block securely lashed to a massive wooden sled. Ahead of this wooden giant, teams of workers would lay down a pathway of sturdy logs, acting as rollers. As the sledge was pulled forward by hundreds of laborers using ropes, it would glide over these rollers. The critical trick was lubrication. Workers would walk alongside the moving sledge, constantly dousing the track with water or a slick mixture of mud and clay. This thin layer of liquid dramatically reduced the friction between the wooden sledge and the wooden rollers, turning a sticky, grinding drag into a surprisingly fluid slide. This system did more than just ease the pulling. It cleverly distributed the stone's enormous weight across many points of contact. Instead of the sledge digging a deep trench into the earth, its load was spread out, preventing it from becoming hopelessly stuck in soft soil. It was a continuous, rhythmic dance of motion and preparation. As the sledge moved forward, rollers from the back were frantically picked up and carried to the front, creating an endless, rolling road that moved with the stone itself. This method, beautifully depicted in ancient Egyptian tomb paintings, required staggering coordination and a clear, prepared path. But this elegant solution had its limits. On steep inclines, across rocky outcrops, or through dense forests, laying down and retrieving a continuous track of rollers became wildly impractical. So how did ancient builders navigate these more chaotic landscapes? Another method, one that seems almost too simple to be true, might just hold the answer. Another ingenious solution for treacherous ground was the leverage and pivot technique, a method that gave the stone a kind of rhythmic, lumbering walk. Where a smooth road of rollers was impossible, across fields of broken rock or up steep, uneven slopes, workers would use the stone's own immense weight against it. They would position heavy wooden levers at strategic points beneath the block. Then, on a coordinated command, a team would push down, rocking the massive stone upward and ever so slightly forward. Before it could settle back into its original position, other workers would quickly shove small wooden chocks or rounded stones underneath the newly lifted edge. The great block would then tilt and pivot onto these new fulcrums. It was a process of constant, tiny adjustments, a slow-motion dance of lift, pivot, and settle. The progress was achingly slow, perhaps only a few feet per day, but it was progress nonetheless. This method offered unparalleled control, allowing crews to navigate around large boulders or through tight, twisting passes that would have stopped a sled in its tracks. The true genius lay in its simplicity. It required no prepared pathway, only human strength, sturdy levers, and an almost limitless supply of patience. The rhythmic, percussive sound of wood straining against stone must have been the soundtrack to these journeys, a testament to a different kind of engineering, one based on incremental victory over an unyielding landscape. But what happened when the path of the stone was blocked not by rock or hill, but by the even more formidable barrier of a wide, flowing river? When the path of the stone met the edge of a river, the entire nature of the journey transformed. Our civilizations blessed with navigable waterways, the river itself became the most powerful ally. The solution was as elegant as it was effective, constructing massive rafts or barges from immense logs, lashed together to create a buoyant platform capable of supporting a weight that would sink a conventional vessel. In some cultures, this principle was taken a step further with the use of inflated animal skins, dozens of them tied beneath a wooden frame to provide the necessary lift. Once a block was painstakingly coaxed onto this floating cradle, the work shifted from brutal pulling to skillful navigation. The current of the river, or the wind in a sail on coastal routes, could now do the heavy lifting, moving the stone for miles with a fraction of the land-based labor. The evidence for this is etched into the landscape itself. Near ancient Egyptian quarries, archaeologists have discovered colossal, unfinished obelisks still lying at the bottom of canals, clearly intended for water transport but abandoned during their creation. These sunken giants are silent proof that water-based logistics were not just a theory, but a central pillar of their monumental strategy. Mastering this form of transport unlocked entirely new possibilities, allowing rulers to dream on a grander scale, sourcing perfect stone from distant quarries and shipping it directly to the heart of their cities. Yet this waterborne miracle came with its own formidable hurdle, a challenge of balance and precision that occurred at both ends of the voyage, loading the stone onto the raft and then unloading it at its final destination. The transfer of a stone from solid ground to a floating vessel was a moment of breathtaking tension. Picture the scene, a riverbank transformed into a massive construction site. A temporary pier built of timber and packed earth extended into the water, serving as a stable platform for the delicate operation. The colossal block, still resting on its wooden sledge, would be carefully maneuvered onto this structure. The real genius lay in aligning the height of the pier perfectly with the deck of the waiting barge, often by exploiting the natural rhythm of the tides. At high tide, the barge would be floated in and secured directly against the pier, its deck now level with the ramp. Workers could then pull the sledge directly across, a seamless transition from land to water as the barge gently settled under the staggering new weight. In areas without significant tides, a different kind of hydraulic engineering took over. They might deliberately dig a canal channel right up to the loading area, intentionally flooding it to float the barge into position, then slowly drain the water to lower the vessel, creating a stable, level plane for the transfer. This entire process was a calculated risk of physics. A single misstep in the pull, an uneven distribution of weight, or an unexpected shift in the current could send the entire assembly, stone and barge, tipping into the river. Success depended on an almost intuitive feel for balance and buoyancy, knowledge passed down through generations of master builders. Once secured, the river current or a team of rowers in smaller guide boats would take over, carrying the stone on the easiest leg of its long journey. But the same nerve-wracking procedure had to be repeated in reverse at the destination. There, another temporary port would be waiting, another set of ramps and ropes ready to coax the mountain back onto the land. This cycle of loading and unloading was a testament to sophisticated project management, a deep understanding of local environmental conditions, and a community's unwavering resolve. With the stone safely delivered, we are left with the ultimate question: what force could possibly motivate and power such an immense, multi-generational endeavor? The true engine behind every stone's journey was not wood or water, but human will organized on a staggering scale. This was a symphony of synchronized effort, demanding the coordination of hundreds, sometimes thousands, of individuals. In societies like the Inca Empire, this colossal undertaking was often framed as a communal duty, a form of labor service known as mita that every able-bodied person owed to the state. It was a rotation system where communities would send their workers for set periods, ensuring a continuous, organized workforce for projects that spanned years or even generations. The act of moving a mountain of stone became a civic and spiritual obligation, a shared endeavor that wove the community together. The managerial challenge was immense. Just picture the scene: 1,000 people gripping massive hemp ropes, all needing to pull in perfect unison on the command of a single foreman's drum or horn. A single misstep, a moment of lost rhythm, could mean disaster, snapping ropes and sending the stone careening dangerously. This required not just muscle, but a clear chain of command, meticulous planning for rest and provisions, and a shared understanding of the monumental goal. The social structures that enabled this mobilization are as fascinating as the engineering itself, revealing cultures capable of uniting entire populations behind a single, breathtaking vision. Yet even this vast human engine had its physical limits, a reality that prompted ancient engineers to recruit a different kind of power. The immense power of domesticated animals offered a revolutionary advantage to ancient engineers. In many parts of the world, the sheer muscle of oxen, water buffalo, or even elephants was harnessed to the great ropes, multiplying the pulling force available to move these stones. A single team of well-trained oxen could do the work of dozens of people, allowing a project to proceed with a smaller crew or to tackle blocks of even more staggering weight. This was not a simple replacement of human labor, but a sophisticated partnership. Specialized handlers possessing a deep understanding of animal behavior were as crucial as the engineers themselves. They knew how to guide these powerful creatures, to keep them calm amidst the chaos of shouting and the strain of heavy loads. Yet, this powerful assistance came with its own demanding logistics. A team of oxen required vast quantities of fodder and a constant, reliable supply of fresh water, turning the transport route into a moving buffet that had to be planned and supplied with military precision. The integration of animal power was a clear technological leap, a deliberate choice to expand the boundaries of the possible. It created a powerful synergy where human intelligence directed the raw, relentless strength of nature's greatest engines. But even this combined force of human and animal muscle had to bow to the ultimate authority of the landscape. The terrain itself held the final veto over every plan, forcing builders to invent solutions for Earth's most formidable obstacles. The landscape itself was the final, unyielding architect of every transport plan. When a mountain stood between the quarry and the sacred site, ancient engineers did not simply go around it, they often went over. In the steep valleys of the Andes, we see evidence of this audacity in the form of carefully engineered switchback paths carved directly into the mountainsides. These were not gentle trails, but calculated roadways designed for a single, terrifying purpose: to control the descent of a multi-ton stone. The primary challenge was no longer pulling, but preventing the colossal block from accelerating into an uncontrollable, destructive avalanche. The solution was a system of sophisticated braking. Teams of workers would use massive ropes, likely made of braided leather or tough plant fibers, tied securely to the sledge and anchored to sturdy trees or rock outcroppings further down the path. As the stone began its descent, these crews would slowly pay out the rope, creating a controlled, frictional drag that kept the movement to a safe, crawling pace. It was a high-stakes dance with gravity where a single snapped rope could mean catastrophe. In the stark opposite environment, the sucking mire of a swamp presented a completely different puzzle. Here, the ground offered no solid foundation, threatening to swallow the stone and its transport system whole. The answer was a brilliant innovation known as a corduroy road. Workers would fell countless trees, stripping them of branches and laying the logs down side by side, perpendicular to the direction of travel. This created a floating roadway of wood, a stable, distributed surface that could bear the immense weight without sinking into the soft peat or clay below. Walking on such a path today, you can almost feel the ingenuity, the way it turns a treacherous, liquid landscape into a firm, reliable highway. The logs themselves acted as both road and rollers, allowing the sledge to slide more easily while simultaneously protecting it from the bog beneath. Each extreme, from the crushing slopes of a mountain to the bottomless grip of a swamp, demanded a unique, site-specific solution. There was no universal manual for moving mountains. Instead, success relied on a deep, localized knowledge of the environment, an understanding passed down through generations of builders who learned to read the land like a map. This adaptability is the true mark of their genius. They did not force a single method onto the world, but listened to the challenges of each valley and forest, inventing the perfect answer for that specific place and time. This intimate relationship with their surroundings leads us to the final piece of the puzzle, the very tools that made such brilliant adaptations possible. The true power of this ancient toolkit lay in the perfect marriage of simple materials and profound knowledge. Ropes woven from tough plant fibers like hemp or papyrus were not just cords, they were the sinews of the entire operation. These were not the simple strings we think of today, but thick, braided cables, meticulously crafted to withstand the bone-jarring shock of a multi-ton load. A single rope pulled by 100 people could channel a staggering collective force, but its failure meant instant disaster. The sound of a snapping rope under that much tension would have been like a thunderclap, a signal of shattered progress and immense danger. This constant threat meant rope making was a high art, a craft where the knowledge of which plants to harvest, how to twist the fibers, and how to maintain the cables was as valuable as the engineering plans themselves. Alongside these vital ropes, the humble wooden lever was a tool of transformative power. Carved from resilient hardwoods like oak or acacia, a lever allowed a small team to lift a corner of a stone that otherwise defied all human strength. This was the practical application of a fundamental law of physics, using a pivot point to multiply force. The longer the lever, the greater the mechanical advantage, allowing crews to perform the delicate work of inserting rollers or correcting a tilt with a degree of finesse that brute force could never achieve. Yet, even with these powerful tools, precision was paramount. How did they ensure a path was level enough to prevent a catastrophic slide, or that a foundation was perfectly flat? The answer lies in some of history's earliest and most reliable engineering instruments. A simple plumb bob, a weighted string that always points directly to the Earth's center, was their unwavering guide to vertical truth. By sighting along this string, a master builder could confirm that a retaining wall for a ramp was perfectly upright. For leveling, they used water as their ally. A shallow, narrow trench filled with water becomes a naturally level surface, a principle they harnessed with simple sighting tools to check the grade of a road for miles. This was not guesswork, it was applied science. The true genius was not in the tools themselves, which were elegantly simple, but in the deep, intuitive understanding of the physical world held by the people who wielded them. This knowledge was a living library, passed not through written manuals, but through the shared experience of 1,000 lifts and pulls, through the feel of a lever in the hands and the sound of a rope under strain. This intellectual framework, this collective mind, was the ultimate engine behind the stone's journey. The rhythm of the stars and the turn of the seasons provided the ultimate timetable for these colossal projects. Ancient builders did not see the cosmos as a distant mystery, but as a practical guide for their earthly endeavors. Their deep astronomical knowledge likely dictated the precise timing for moving mountains of stone. For example, the annual flooding of the Nile River in Egypt transformed the arid landscape into a network of navigable waterways. A master planner would have known that the ideal moment to transport an obelisk was during the height of the flood, when the stone could be floated on barges for miles with the current doing most of the work. Similarly, in other climates, the wet season's muddy ground, a hindrance to foot traffic, could become a slick, natural lubricant for a heavy sledge, dramatically reducing the friction that hundreds of laborers would have to overcome. This celestial scheduling extended to the human workforce as well. The mass mobilization of thousands of people had to be synchronized with the agricultural calendar. Large-scale moves were likely planned for periods after the harvest or before the planting season, when the majority of the population was freed from their work in the fields. This was not a random gathering, but a carefully orchestrated event, perhaps even tied to religious festivals that gave the back-breaking labor a deeper spiritual meaning. In this worldview, pulling a stone to a temple was not just construction. It was a form of participation in the cosmic order, aligning human effort with the movements of the sun, moon, and stars. This seamless fusion of cosmology and logistics reveals a holistic intelligence where understanding the heavens was as crucial as understanding lever mechanics. But how can we be so sure that ancient people planned with such intricate detail? The proof is not found in a single manual, but woven into the very fabric of the sites they left behind. These physical traces are the silent witnesses to the monumental efforts of the past. Deeply grooved cart ruts, like those found cutting across the limestone landscape of Malta, are more than just curious scars on the rock. They are the direct result of countless journeys, the relentless passage of heavily laden sledges or carts following the exact same path, year after year, until the very stone itself gave way. The depth and polish of these grooves speak to the immense, grinding weight they were designed to bear, mapping out ancient transport routes as clearly as a modern highway. Elsewhere, abandoned stones tell a different kind of story. The unfinished obelisk in Aswan, Egypt, remains partially attached to the bedrock, a project halted mid-creation. This colossal failure is an archaeologist's treasure, a frozen moment that reveals every step of the quarrying process. The tool marks left by stone pounders are still visible, showing exactly how workers channeled the base of the obelisk, while the cracks that ultimately doomed the project offer a sobering lesson in the limits of their technique. These abandoned giants are not symbols of defeat, but candid snapshots of the immense challenges these builders faced daily. Even the smallest marks left on quarried surfaces can be read like a forgotten language. The patterned pitting from stone hammers, the clean lines left by driven wedges, and the smooth scoops from adzes each tell us which specific tool was used and how it was wielded. This is the ancient equivalent of an instruction manual, written not on papyrus but in stone itself. Interpreting this physical evidence allows us to reconstruct their methods with remarkable clarity. We can see where they started, how they corrected mistakes, and sometimes precisely why a particular approach succeeded or failed. Each groove, each fractured block, and each chisel mark is a piece of a vast, scattered puzzle. Together, they form a material record of perseverance, a story of trial, error, and ultimate triumph over the physical world. yet stone alone cannot tell the whole story. To fully understand the motivation that fueled such immense labor, we must turn to the cultural records and oral histories that have been passed down through generations. Beyond the physical grooves and tool marks lies another kind of evidence, one carried on the breath of generations. The oral traditions and mythologies of indigenous cultures often hold the cultural memory of these colossal undertakings. While not literal history books, these stories are not mere fantasy either. They are a different way of encoding knowledge, where the line between the human and the divine, the possible and the miraculous, is beautifully blurred. Tales of gods or giants single-handedly moving mountains might be powerful metaphors for the collective strength of an entire community united in a single, staggering task. The feat was so monumental that it could only be explained through the language of the supernatural. Consider the legends found across various Pacific islands, where stories speak of great canoes or rafts that carried sacred stones across the sea. These are likely the preserved echo of a very real and sophisticated water transport system, a cultural memory of how ancestors navigated the ocean to bring their most important materials home. Deciphering these narratives requires listening not for literal truth, but for the embedded wisdom about methods, social organization, and the profound cultural weight of the project. The specific mention of a canoe, for instance, points directly to the technological solution they employed. The reverence given to the stone in the story reflects its ultimate purpose in a temple or monument. This blend of myth and reality does not simplify the mystery, it deepens it, adding a rich layer of human meaning to the engineering puzzle. To see how all these pieces fit together, from the quarry to the myth, we can turn to a few of history's most iconic and enigmatic examples. The iconic Moai of Easter Island present a transport mystery that feels almost magical. These colossal stone figures, carved from compressed volcanic ash, were somehow moved for miles across a rugged landscape. The most compelling modern theory suggests the statues did not slide, but walked. Researchers propose that the Moai were engineered to rock from side to side, kept upright by teams pulling on ropes tied at the statue's head and base. In a carefully coordinated dance, one crew would pull a forward rope, tilting the giant forward onto its curved belly, while another team on the side would use ropes to control its sway, preventing a fatal topple. This rhythmic, rocking gait would have allowed a surprisingly small group to guide the multi-ton figure across the island's rolling hills. This method was a perfect adaptation to a place with limited timber for rollers or sledges, turning the statue's own mass and shape into the primary tool for its journey. Yet this walking technique, so elegant in theory, was incredibly precarious in practice. The island is littered with Moai that never reached their ceremonial platforms, fallen giants that bear silent witness to the fine line between success and disaster. The very idea that a community could make a stone giant walk speaks to a profound understanding of physics and balance. But could such a delicate, dynamic method have worked on a larger continent with different stones and terrain? To explore that, we must look to another part of the world, to the colossal stones of Baalbek in the Levant. The trilithon at Baalbek confronts us with a scale of ambition that defies easy explanation. Here, in the heart of the Bekaa Valley, the Romans placed 3 limestone blocks, each weighing nearly 800 tons, high in the wall of a grand temple complex. To put that weight into perspective, each of these stones is heavier than 2 fully loaded jumbo jets. The quarry itself lies less than a kilometer away, a short distance that belies an almost unimaginable feat of logistics. There you can still see the source of their ambition, an even more massive block known today as the Stone of the Pregnant Woman. This abandoned monolith, still partially attached to the bedrock, is estimated to weigh over 1,000 tons, a stark reminder of a project that even the Romans could not complete. Moving the three giants they did succeed with required a level of coordination that pushes the boundaries of what we think was possible. The method was almost certainly a titanic version of the sledge and roller system, but scaled up to a staggering degree. Imagine a wooden sledge the size of a small house, carrying its mountainous load, resting on a road of countless logs. Now picture the workforce, not hundreds, but thousands of laborers, their muscles straining in unison against immense ropes woven from hemp. Alongside them, teams of oxen, perhaps numbering in the hundreds, added their brute strength to the pull. This was not a simple tug of war. It was a carefully choreographed ballet of human and animal power, all moving to the beat of a single drum or the call of a master engineer. The pathway itself would have been a major engineering project, a meticulously leveled and reinforced road designed to bear a concentrated weight that would have shattered ordinary ground. Every component, from the strength of the ropes to the durability of the wooden rollers, had to be perfect. A single failure in this chain would have been catastrophic, potentially destroying the stone, the sledge, and claiming many lives. The successful placement of the trilithon blocks was a statement of absolute imperial power, a declaration that Roman engineering could conquer any physical limitation. It stands as a permanent monument to what human beings can achieve when their will is channeled through brilliant organization and sheer, undaunted effort. From the sun-drenched temples of the Mediterranean, our journey takes us to the misty green hills of the British Isles, where an even older mystery stands in silent circles of stone. The journey of the Bluestones to Stonehenge stands as one of history's most incredible logistical puzzles. These smaller, yet still massive, pillars of spotted dolerite were not sourced from the local Salisbury Plain, but from the Preseli Hills in Wales, a distance of over 250 kilometers. This was not a straightforward overland trek, but a multi-stage voyage that demanded a deep understanding of the entire landscape. The prevailing theory paints a picture of brilliant adaptation. First, the stones were likely dragged on wooden sledges across the rugged Welsh terrain to a waiting coastline. There, they were loaded onto rafts or secured within the hulls of large dugout canoes. This waterborne leg of the journey would have exploited the natural highways of the sea, sailing along the Welsh coast before turning inland via ancient river systems that reached deep into what is now England. This hybrid strategy reveals a master plan, one that leveraged the easy glide of water transport to save immeasurable human effort, only to return to the grueling work of land haulage for the final approach to the sacred site. Such a complex operation could never have been the work of a single village. It implies a network of cooperation, a chain of communities along the route who shared knowledge, provided labor, and perhaps even traded resources to keep the stones moving. The scale of this coordination is almost beyond comprehension, a society-wide commitment to a single, distant goal. This staggering dedication forces a fundamental question, a mystery that lies at the heart of Stonehenge itself. What profound belief or powerful necessity could compel a people to undertake such a monumental task? The true motivation for moving mountains of stone was not merely architectural ambition, but a profound spiritual imperative. These colossal basalt blocks were far more than building materials. They were considered vessels of divine energy, physical anchors for the gods or the spirits of revered ancestors. In many ancient cultures, specific quarries were not just convenient sources of stone, they were sacred sites themselves, places where the earth's power was believed to be most concentrated. To bring a piece of that powerful earth to a temple or ceremonial center was to physically transport a fragment of the divine, forging a tangible link between the human world and the cosmic realm. The stone's journey was therefore a pilgrimage in the truest sense. Every pull of the rope, every turn of the lever was an act of devotion, a collective prayer made manifest through immense physical effort. This spiritual dimension transformed back-breaking labor into a sacred duty. The shared struggle of moving the stone did more than just build a monument. It wove the community itself into a tighter fabric, creating an unbreakable social bond forged in common purpose and shared sacrifice. The final placement of the stone was the climax of this epic ritual, the moment the sacred fragment was brought home, completing a journey that sanctified both the landscape and the people who moved across it. This understanding of the why is the crucial missing piece in the puzzle. It explains why entire generations would dedicate their lives to a task whose physical rewards they might never see. The spiritual meaning justified the immense investment of time, resources, and human energy, turning a logistical nightmare into a holy mission. Yet, this deep cultural context inevitably leads us to wonder if our modern understanding of their methods is complete. Could there have been lost technologies, forgotten principles of physics that aided them in this sacred work? The sheer scale of these accomplishments has led some to wonder if we are missing a crucial piece of the puzzle. Could ancient builders have possessed a form of technology, a specialized knowledge of tools or techniques that has since vanished from our historical record? This is the compelling theory of lost technology. Some researchers speculate about unique lever systems, far more efficient than the simple logs we imagine, or specially formulated lubricants derived from plants or minerals that created an almost frictionless slide. More speculative ideas even suggest an understanding of sound or vibration, using rhythmic frequencies to somehow make the colossal stones temporarily lighter or easier to maneuver. While direct physical evidence for such advanced methods remains elusive, the theory persists because it addresses the lingering gaps in our understanding of certain feats. It serves as a powerful reminder that history is not a closed book, but a narrative that is constantly being rewritten with each new archaeological discovery. The possibility that an entire branch of practical engineering could be forgotten adds a profound layer of mystery to these ancient sites. Yet for every tantalizing idea of a lost superscience, we must weigh it against the equally remarkable power of accumulated, incremental innovation. The true answer likely lies not in a single forgotten secret, but in the slow, deliberate refinement of simple, brilliant principles over countless generations. Every successful journey of a stone relied on a deep, accumulated wisdom, a library of knowledge built not in scrolls but through hard-won experience. The elegant solutions we marvel at were not sudden revelations, but the refined products of a long, slow process of trial and error that spanned generations. A master builder would have learned his craft not from a textbook, but by working alongside his elders, absorbing countless small lessons. He would know that a certain type of wood made for a more durable roller, or that a specific mixture of mud and water provided the perfect lubricant for a particular kind of soil. Each new project served as a living laboratory. A stone that cracked during transport might teach them to avoid a specific quarry vein. A sledge that repeatedly bogged down in a meadow would force them to innovate, perhaps leading to the creation of a corduroy road for that very stretch. Every failure, every setback was not a total loss. It was a data point, a crucial piece of information that refined the collective understanding. The perfect rope tension, the ideal team size, the most efficient rocking rhythm for a Moai, these were all variables honed through repetition and careful observation. This was a science of the practical, where progress was measured in inches, and the wisdom of the past directly informed the triumphs of the future. Guiding this entire, intricate process were the master planners, the brilliant minds who could see the finished monument while the stone still rested in the quarry. These master builders were the architects of the impossible, turning theoretical knowledge into tangible stone and mortar. Their minds were living libraries of geometry and physics, capable of calculating the precise angle of a ramp or the tensile strength of a rope without a single written formula. They could survey a 20-mile route and visualize every obstacle, every river crossing, and every slope, devising a plan for each segment long before the first lever was ever placed. This was not a democratic process, it was a chain of command. A single chief engineer, his authority unquestioned, would have directed a hierarchy of foremen, each responsible for a specific crew or task. One team managed the rope pullers, another the lever crews, and another the constant maintenance of the rollers and sledges. This clear structure was the only way to coordinate the chaos of 1,000 people moving as one. The knowledge they possessed was so valuable it was often a secret, passed down from father to son within specific families or guarded by powerful guilds. This explains the remarkable consistency in technique across centuries and continents, a signature of a professional class whose expertise was in constant demand. Their legacy is not just in the stones they moved, but in the invisible blueprint of organization they left behind. Yet this relentless pursuit of permanence, this drive to build for the ages, came with a profound and lasting impact on the very land that provided the materials. The shadow of these colossal projects stretched far beyond the quarry walls. Each journey of a stone demanded an immense appetite for resources, particularly wood. The constant need for rollers, sledges, and the massive rafts for water transport consumed forests at a staggering rate. In regions where large-scale construction persisted for generations, this relentless harvesting could have led to significant local deforestation, altering the microclimate and soil stability for centuries to come. The very paths created for this transport became permanent scars on the landscape, deeply grooved roadways and cleared corridors that redirected water flow and changed how both animals and people moved through the territory. This reality suggests that ancient societies were not just master builders, but also early resource managers. They likely understood the necessity of sustainable practices, perhaps implementing coppicing, where trees are cut in a way that encourages new growth from the stump, or deliberately selecting transport routes that avoided ecologically fragile areas. The decision to move a stone was never just an engineering problem. It was a delicate balancing act between human ambition and environmental stewardship. This intricate relationship with the natural world forces us to see these monuments not as isolated triumphs, but as the culmination of a complex, managed partnership with the living landscape. The choices they made in managing wood and land reveal a sophisticated awareness of their dependence on the environment, a lesson etched not in stone, but in the silent history of the forests that surrounded them. The immense stone was more than a physical burden, it was a social engine. Each pull of the rope reinforced a complex web of duties and rewards that defined an entire society. For the ruling elite, orchestrating such a monumental endeavor was a powerful display of authority and a claim to divine favor, proving their ability to command both the human and the natural world. For the thousands of laborers, the work was often a required service, a form of tax paid not with coin but with sweat. Yet this duty was not necessarily a grim oppression. Participating in a project of such grand scale, one that would outlive them for centuries, could forge a powerful collective identity. A farmer who normally worked his own small plot might now stand shoulder to shoulder with hundreds of others, united in a single, rhythmic effort that transformed them from individuals into a single, mighty force. This shared struggle and ultimate triumph built something intangible alongside the temple, a profound sense of communal pride and a story that would be told for generations. The monument became a permanent symbol of what they had accomplished together, a physical anchor for their shared history. Modern attempts to replicate these feats reveal just how much we have lost this collective spirit. Contemporary experiments, often led by archaeologists and engineers, rely on volunteers and scientific instruments. They can prove the physics of a rocking Moai or the efficiency of a lubricated sledge, but they cannot easily replicate the deep-seated cultural motivations, the social structures, or the generational patience that powered the original endeavors. A weekend team of volunteers moving a concrete block for a documentary is a fascinating test, but it is a world apart from a society that dedicated its lifeblood to a project spanning decades. These modern trials highlight the brilliance of the ancient methods, yet they also underscore a profound difference in human organization. The ancient world understood how to channel the power of a unified community toward a single, seemingly impossible goal, creating a legacy of stone that was built not just by hands but by a shared will. These modern experiments strip the mystery down to its physical core, replacing legend with the strain of real rope and the groan of wooden rollers. In controlled settings, teams of archaeologists and volunteers have attempted to recreate the epic journeys of these stones, testing every proposed method with scientific rigor. A concrete replica of an Easter Island Moai was successfully made to walk, rocking back and forth with teams pulling on ropes in a carefully timed rhythm. Yet this experiment revealed a critical, unrecorded detail: the constant, nerve-wracking danger of the statue lurching too far and crashing to the ground. The margin for error was terrifyingly small. Similarly, sledge and roller experiments demonstrate that a lubricated track can indeed reduce friction dramatically, but they also uncover a hidden logistical nightmare. The sheer number of rollers needed for even a short distance is staggering, and the crew tasked with constantly moving them from the back to the front works in a state of frantic, exhausting repetition. What looks like a smooth, steady glide in a theory is actually a chaotic ballet of coordinated labor, where a single moment of miscommunication can jam the entire system. These hands-on trials force a complete re-evaluation of what ancient work crews truly endured. The physics might be sound, but the human element, the management of fatigue, and the sheer psychological toll of controlling such immense weight becomes starkly clear. This experimental archaeology does more than just validate a theory. It breathes life back into the silent stones, allowing us to hear the echoes of shouted commands and feel the tremble of the earth under a moving mountain. Even with all our discoveries, profound gaps remain in our understanding. The most baffling question might be the final one: how were the truly colossal stones, like the 800-ton giants of Baalbek, ever raised onto their towering foundations? We can theorize about immense earthen ramps, built up and then dismantled, or about complex systems of levers and counterweights. Yet the sheer physical reality of lifting that much weight dozens of feet into the air with such precision feels almost supernatural. The silence of the historical record on this specific act is deafening, a secret held tightly by the master builders. Equally elusive is the human spirit behind the labor. We can document the social structures and the labor obligations, but can we ever truly know the heart of a worker pulling a rope for the 1000th time? Was it pure duty, or was there a genuine, transcendent belief that each blister and each aching muscle was a direct offering to the gods? The precise alchemy of fear, faith, and community that powered this engine of effort remains just out of reach. And this forces us to ask an even more provocative question. Are we even asking the right questions? Could there be a fundamental principle, a simple method of manipulating weight and balance, that our modern minds have simply overlooked because it seems too straightforward? These are not failures of research, but the very forces that drive the field of archaeoengineering forward. Every unanswered question is a beacon, guiding the next generation of explorers and thinkers. This humble acknowledgement that the past still holds profound secrets is not an admission of defeat, but a celebration of the endless mystery that lies at the foundation of human achievement. The story is not finished, it is simply waiting for its next chapter to be written. A fascinating pattern emerges when we map the journeys of great stones across the globe. The Olmecs of ancient Mesoamerica, who transported massive basalt heads from distant quarries through dense jungle and swamp, developed a solution perfectly suited to their world. They likely used rafts and log rollers, capitalizing on the region's extensive river networks, yet their approach was distinct, shaped by an environment rich in water but challenging for overland haulage. Across the ocean, the megalithic builders of Europe faced a different set of obstacles. In the rocky, glaciated landscapes of places like Scotland and Ireland, they perfected the art of leveraging and pivoting stones across uneven ground, a method less dependent on the vast timber resources needed for sledges. This comparative view is illuminating. It shows that the fundamental physics of moving immense weight, the principles of leverage, friction reduction, and weight distribution were understood universally. These were the shared tools in humanity's collective toolkit, yet how those principles were applied varied dramatically, a direct reflection of local geography and the materials at hand. A culture surrounded by dense forest would naturally turn to wooden rollers, while an island society with limited trees might invent a walking technique for their statues. The specific solution was always a dialogue between human ingenuity and the unyielding reality of the local earth. This diversity of method underscores a profound truth about our shared history. While separated by continents and millennia, these cultures were all answering the same fundamental call, a drive to create something permanent and meaningful that would echo through the ages. That ancient rhythm of levers and ropes still beats at the heart of our modern world. Look at a construction site today, and you will see the direct descendants of those first principles. The steel cables hoisting a girder high above a city are performing the same function as the immense hemp ropes pulled by 1,000 hands, just with greater tensile strength. The hydraulic jack, capable of lifting an entire building, is the spiritual successor to the wooden lever, applying focused, multiplied force with mechanical precision. The fundamental physics of moving immense weight have not changed, only the materials we use to harness them. This legacy is most evident in large-scale projects that echo the communal efforts of the past. Consider the installation of a massive bridge girder. It requires the same meticulous coordination, the same clear chain of command, and the same understanding of balance and distribution that guided a stone onto a sledge. The project manager with a digital blueprint stands in for the master builder reading the landscape, both orchestrating a symphony of synchronized effort. This continuity reveals a profound truth. Our most advanced engineering is not a rejection of ancient wisdom, but its ultimate refinement. The real lesson for our future may lie in looking back at their relationship with energy. In an age concerned with sustainability, these low-energy methods offer a powerful inspiration. What if we revisited the idea of using gravity and controlled friction, perhaps with modern materials, to move heavy components with minimal carbon footprint? The ancient builders were masters of working with the environment, not just conquering it. Their achievements challenge us to build our own monuments not only with power, but with profound intelligence and respect for the forces that have always shaped our world. The movement of these stones stands as a permanent monument to human ingenuity. It was never just a matter of physics and engineering, but a profound expression of what people can accomplish when they unite behind a shared vision. From the moment a block was fractured from the quarry wall to its final, sacred placement, the entire journey was a cultural masterpiece, a symphony of coordinated effort that transformed raw stone into a legacy. We may never uncover every secret of their methods, and perhaps that is part of their enduring power. Each new discovery, whether from a weathered tool mark or a modern experiment, brings us one step closer to appreciating the full scope of our ancestors' capabilities. Their story challenges our own perceptions of limitation, reminding us that the boundaries of the possible are frequently drawn not by our resources, but by our collective imagination and resolve. We would love to hear which of these ancient mysteries captivates you the most. Share your thoughts in the comments, and if you enjoyed this journey, subscribe for more explorations into the forgotten stories that shaped our world. The great book of human achievement is still being written, with every new chapter waiting to be uncovered. If this journey into the minds of ancient engineers has sparked your curiosity, there is a whole world of historical puzzles waiting to be unraveled. Your engagement directly fuels our ability to seek out these incredible stories and share them with you. By liking this video and subscribing to our channel, you join a community of explorers dedicated to uncovering the secrets of our shared past. So we turn the question back to you. What incredible feat from history would you love to see us investigate next? Was it the precise celestial alignment of forgotten temples, or perhaps the ingenious water management of a desert civilization? Share your thoughts and suggestions in the comments below. Let's continue this conversation and build our next adventure together. Thank you for your time and your sense of wonder. Never stop looking for the extraordinary hidden within the ordinary world.